Okay, never mind. Okay, 2.6. Okay, 2.6. We're gonna learn the differential equation other than three types: separable, linear, exact. Okay, what if differential equation is none of them? How can you deal with that? So that's the problem in 2.6, and then we can figure out this answer for that question. So I forgot the name of the chapter 2.6, but one second, right here. But definitely we're gonna learn four types other than separable, linear, exact. So first in 2.6 and type 1. So see, type 1 is homogeneous equation. So homogeneous equations has the form, type 1, has the form dy dx. Take a second. Okay. Dx is equal to g of y over x. Okay. When you rewrite differential equation, first order linear equations as the like this, dy dx, and left hand side alone, and then right hand side a function of y over x. If you can express the function on the right hand side as a function of y over x, then that's going to be homogeneous equations. Then we'll see example later, but I think it's I should introduce strategy first. The strategy. So we're gonna substitute v is equal to y over x. So v is a new variable. Okay. Then dy and the dx is equal to v plus x times dv and the dx. Okay. So you see, this is what now this is going to be separable. Okay. I mean, once you substitute this one into dy dx, okay, then you can see then you can get the separable equation. So using this one and with this, you can completely transform that differential equation to the separable. Okay. So it's homogeneous. It's homogeneous right here. Transform to separable. Okay. Next one is the so here type 2. By the way, did you get it? Why this v dy dx is equal to v plus x times dv dx? So you just take a derivative v with respect x. Understand that? Right there. What here is take a derivative v with respect x. Here, keep in mind this, y is a function of x. So we have to apply chain rule. Then d what? Y prime. This is gonna be what? Y prime times 1 over x. I mean, let me apply the product rule, okay? Plus, and then y times 1 over x prime. Here, prime means d dx. Then y prime gonna be what? dy dx, right? Okay, times 1 over x, right? Now plus, this is gonna be what? Y times minus, right? 1 over x squared, isn't it? So now this is equal to here, right? And then now look at this right here, this one, right here. Then let me solve this one for dy dx. Then dy dx is equal to, right? Is it x times y and then 1 over x squared, right? Plus x times dv dx. Is it? So now here, this is equal to x, and then x will cancel them out. We got y over x, which is v. Because we set v equals y over x. So y over x is going to be v, and then plus x times dv dx. Why we need to do that? Because once you change the variable to from y and x, y over x to v, right hand side is going to be g of v, right? This is a function of v. But left hand side is still dy dx. Doesn't make sense. Change the dy dx means what? Infinitesimal rate of change of y with respect to y is equal to the function of v. This is a kind of function of x, right? This is a function derivative of a function of y, or not function of y with respect is equal to function of v. Doesn't make sense. We have to unify the variable. If this is something of v, we have to re-express this one as in terms of v. So in order to rewrite this one in terms of v, we need to take a derivative v with respect. So now here we're going to substitute this one into here, into there. And then v plus x times dv dx is equal to g of v. Now dv dx is equal to what? G of v over x minus, right, v over x. So we completely transform the differential equation to this one, and this is separable. Makes sense, right? We'll just multiply by x and the multiply dx, right? The divide by dv, then this is separable. Okay, this is separable now. Or you can you don't have to rewrite this one as this. Yeah, from there, you can say this is separable. This is separable too. Okay. So in this step, you can just separate the terms and x terms. Doesn't matter. Then second type 2, is the equation of the form dy dx is equal to g of ax plus by. Okay, here's the strategy. So we let z is equal to ax plus by. And then the z dx is a plus b times dy over dx. So dy dx is equal to g of ax plus by. This is similar to what we did in type 1, homogeneous equation. So we just substitute z for ax plus by. Okay, so that the right-hand side differential equation turns out to be a function of z. Okay, and then we're gonna rewrite dy dx in terms of z. Okay, so here taking derivative z with respect to x, then we get this, right? We're gonna get this. So we are plugging a plus b times, this guy into the left-hand side in differential equations, and then the right-hand side is gonna be g of z. Okay. So anyway, so this is the original differential equation that we transform by using substitution to separable. Okay. Now you strategy, right? Look at the type 1 and 2. These two guys, the strategy is to transform using substitutions, transform to the original differential equation to the separable. Which means that what? We know the separable, we know how to solve the separable, linear, and exact, right? So for something that equation, what we don't know, then we're gonna using the substitutions, we're gonna transform the differential equation to the known type of differential equation. That's a strategy. So into type 3. The Bernoulli equation. Let's see this equation. So Bernoulli equation has the form of this dxy and then q of x and then y to the nth power. Okay, y to the nth power. So if n equals 0, linear. If n equals 1, linear. It's not a big deal to deal with that, right? So if n is so n is greater than or equals 2, okay? So it's got this equation not going to be linear anymore. What are you going to do? So we use the strategy, the substitution. So let v is equal to y to the 1 minus nth power. Okay, then the dv dx is going to be 1 minus n times y to the minus nth power, and then dy dx. Okay. So using this one, that substitutions, we can transform the Bernoulli equation to linear. These are Bernoulli equations right here. Transform this one to linear. Okay. So the last one. Type 4. Linear coefficient. So okay, hanging there, almost done. A1x plus B1y. The equation is quite long. Okay, so A1x plus B1y plus C1 times dx. It looks like exact, no, it's not exact. Okay, not exact equation. A2x plus B2y and then plus C2 dy is equal to 0. So here strategy is quite complicated. Listen carefully. So for A1 times B2 is not equal to A2 times B1. Where that comes from? That comes from the determinant actually in the matrix. This is system. We look at this is first equation is system, this is second equation system. And then from there, taking out the coefficient to construct the matrix, except for C1 and C2. I know, okay, so never mind. All right, that's too much. Okay, for A1, B2 is not equal to A2, B1. So, and then let the x, yeah, like other types, the strategy and types, we use a substitution method. X is equal to U plus H, okay? And y is equal to V plus K. Sorry, this is K. Okay. So where H and K satisfy A1 H plus B1 K plus C1 equals 0, and then A2 H plus B2 K plus C2 equals 0. Okay. So linear coefficient. Okay. What are you going to do? Here's a linear coefficient differential equation given. Okay, let's say. We transform to the homogeneous. Okay. How? Using that substitution. X equals U plus H, Y equals V plus K. And then you can find the H and K by solving that system. See that C1, C2, B1, B2, A1, A2 are given, right? H and K are only unknowns. Two solution equation with two unknowns is solvable, right? So we can find H and K, right? So that we can completely substitute X and Y and U plus H and V plus K into X and Y. Okay, then you can rewrite that differential equation as homogeneous. Now, then what? Using the substitution, we can transform homogeneous to separable. So now let W is equal to V over U. Okay, then what? dV du. Now here, keep in mind is V over U. Now V is what? That V is V over U. So V is a function of U. Keep in mind this. dV du is equal to W plus U times dW over d what? U. Using that substitution, we can transform homogeneous to what? To the separable. Okay, so especially it's type 4, you have to apply the two substitution. Okay, first using that substitutions transform linear coefficient to the homogeneous, and then using that substitution transform homogeneous to the separable. Okay. So 2.6 is talking about this type 4. Yeah, type 4. Let's see.